B, Unit 7, preparation for Assessment 1. All right, so here comes the deal. If you know what you're doing, you'll do it a million times, so that's good news. 25 cents, 50 cents, 75 cents, a dollar. 25, 50, 75, a dollar. One up, one down. Unlike sign, where we put something on the 25 and the 75, above 25, below 75, this time it's going below the 50 cents. You're going up high on the 1 and the 100. And then the 75 and 25, they get their own dot, like just right on the line. From there, you start the roller coaster up high. This is the original. This is the parent function. Slide through. That was in the video. So that's why I thought, like, dang, why not like, oh, this is easy? Because I didn't get through, or even if it did, why would I watch a video sent by a math teacher? Clearly, it's gonna be a math video. It's not gonna be like Rihanna's new, you know what I'm saying? I don't even know if she has a new.
She doesn't make music.
Oh,
It's so
okay.
annoying.
All right. So here's the deal. Next one. What are you actually doing for this thing? I'll do it all in blue. My 25s, they stay in place. This guy won't. Oh, shoot. Let's move it to the left. So I need pi. If you don't know where pi is, you got to turn these guys. I'm going to turn them into numbers first. A complete circle, that's what I need. Oh, for the key assignment. Yeah. So this is going to help for the key assignment. 360, half 360 is 180. Half of 180 is 90. What's this? My 9 timetable is 9, 18, so it's a 27. Add a 0. It's the pi thing that's going to be important for this. If they talk about pi, you got to know, well, where's pi? How much is pi?
It's pi and 50 and 180.
Let's find out. The whole entire circle is 2 pi's. Half of that is 1 pi. Boom, that'll get it done. Half of a pi is just half of a pi. Ooh, this one here was supposed to be hard. I got a new technique on it. Anybody remember what my new technique is for this one?
Is it like 3 pi over 2?
Yeah, 3 pi over 2 just because we're smart. But my technique is that this guy is just like this guy. See this pi over 2? Pi over 2. As a matter of fact, everybody's a pi or pi over 2. There's only one person trying to sneak. Remember that 3 was trying to break up that relationship in the last problem? 3 is trying to break this relationship up too. All right. In any case, now that I have this, now I know how much I'm shifting this pi to the, what do we say, to the right, to the left?
Right.
Yeah. Inside here, it has to be the opposite. Negative numbers are usually that way, so you figure, oh, negative pi is that way. But because it's inside the parenthesis, we're going to shift it that way. Let's shift it that way in blue. What does it mean shift it that way? So here is pi. Originally, we started here. This is where the whole thing started. Oh, it's not even going to fit on my thing. So it's going. I'll do half of it or whatever. But the whole original line, this is thanks to, what's the dude's name? He's around still. Ryan Dill. Ryan Dill, the student. I'm doing the hard way. I'm trying to move each dot. Okay, I'm going to move you over to, move you over to, move you over to. Ryan Dill, he moves the starting post over because he knows after he moves from the starting post, he knows 25, 50, 75. He knows that. So he moves this whole starting post over pi. There's pi. So shift the whole thing over to pi. Then he draws this thing here while I'm doing the long way. Now he's kicking back, talking, and doing whatever. So I'm thinking, Ryan is messing around. He's sitting there. So I'm like, hey, Ryan, you're already done? Oh, yeah, I'm done. And then I think they're like, is that a small sheet that has several? And I think he hit like 2 or 3. I'm still moving the dots. I'm like, dude, what'd you do? He explained he moved the starting point. And then from that, he then started counting 25, 50, 75, a dollar. And then after he did that, it's like we're not looking at this part anymore. I know it's going to be all mixed in, but for me, now I know one's still up here, and I know negative one's still down there. And so let me put in my new numbers in blue so it can be all confusing for whoever's watching the video, which, by the way, is nobody. Just for the record, yeah. What's up, Andrew? You want to come in? You want to say something? I'm only teaching. All right, yeah. So here goes. 25, 50. He's thinking 75, a dollar. Once you have that, yeah, he forgot it, but that means he didn't give me my pencil back. But he'll bring a pencil back next time to exchange for that, yeah? Maybe 2 pencils.
Okay.
All right, well, think about it. All right, so here's the deal. Above, let's see, greenish, so I can mix everything up. Something out there, some over here, if I could fit. something below the new 50. Where are you, new 50? Clink, clink. Oh, shoot, this thing's going up to 2. Ah, shoot, 2 is all the way up there. All the way up high. And a negative 2, where are you? You're 1. Shoot. Yeah, this is all messed up. Don't watch this video. No matter how much you want to watch it, don't, because it's going to be confusing. Amplitude says take it up to the 2nd floor, not the 1st floor. The 1st floor is for babies. All right, here you go. Woo! I don't want to write on that. You're all the way down here. Oh, yeah. Put the new stuff in blue. All these colors. Hey, Thomas, how can you make this more confusing? Oh, I don't know. Just put a variety of colors. Say a variety of junk. Still, I'm going through the 25. That's you. There's a 75. Here it comes. It's like the screamer. Yeah, that was fun. Yeah, the ride's over because it's slowing down. New starting line, because I shifted it over. Pi. New dots, clink, 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 clink. Amplitude, amplitude, went up high, and amplitude went down low. This is making it even worse than before, but whatever. I'm not going to be watching it. When you are graphing old school, you have a y-axis, you have an x-axis. Someone gives you a coordinate that gives you something like a 2, 3, no big deal. You go 2 to the right, and then you go up 3, and voila, you have 2, 3. Okay? That's a long time ago, no big deal. Someone gives you, this was on the test, some people missed it, they give you maybe negative 2, 3. Well, you back up negative 2, you go up, 3, negative 2, 3. No big deal. The waves, the sine waves, they've just changed the names of what used to be x and what used to be y. Back in the day, we know x, you go left and right, y, you go up and down. What if they changed the name of it and called, instead of it x, they called it cosine? And they called sine, or they called the y the sine. So on the test, they said, please write 3 angles where you have a negative cosine and a positive sine. And some people just weren't sure what to do. All they were saying is, what if you had to go back negative first and then go up positive second? Where would you end up? Oh, I'd probably end up like right here. Okay. The wave takes 2 separate things. In other words, let's see if I can say this. Let's erase some of this. How can I say it? Let's start with this. Here, this is 0 degrees. This guy is 90. This guy is 180. This guy is 270. Most of you know this. If I were putting money on it, which I am about to put the money, so hopefully when I put the money over here, you're like, oh, wait. So they're tearing the circle open and stretching it out into a straight line? I have 25 cents, 50 cents, 75 cents, and I got my dollar. Over here, when we're drawing the picture, normally we do, let me do my dollar first. I do my 50 cents, my 25 cents, 75 cents. Okay. Essentially what this line is that you've been doing forever is a circle that you have the power to tear apart and stretch out. Here's the 0 of the circle, the 0 degrees. Where am I? You are 360. You're 180. You're 90. And you're, what's that in between me, 270. So when they tore this circle apart, here is 0. They lined it up right there. There's 90. They just laid it straight out. Then the 180, the whole thing is stretched out. Okay, so this line here, if I could, wish I had a highlighter. This line from here to here represents a circle that they tore open and laid it down right on the ground. The question is, well, what's the wavy stuff? Like, what is that? What part of the circle is that? Here comes the answer. Hopefully you said okay. For cosine, which is what we're looking at, for cosine, cosine represents the x-axis. In other words, from here to the edge of the circle equals a 1. That's this one here, and that's this -1 down here. The radius of the circle is 1. The question is at 0 degrees for cosine, how far out did this red line go to reach this point right here? The length of this is a 1. In other words, when we begin the cosine wave, it starts up there at 1. Because this red line in between here, as I'm going to move this shifter, you're going to see it gets smaller and longer, but let's see if I can erase this and move it a little bit. Come on so they can see it. Look at this red line here. This is cosine. Red line gets longer, it gets shorter. Longer, it gets shorter. The only thing that red line can do is go from left to right. It is stuck in this circle, so the best it can do is go all the way to the wall. It can come back to the middle and go to the other wall. That's all that red line can do. And that red line that keeps going left and right is what we call cosine. So let's find out what it's doing at 0. At 0, it's as longest that it can be. It is a full-on 1. That's the longest it can be because those walls are only from here to here 1, from here to here 1. The minute the degrees start going around the circle, ooh, stalker. Oh, see, I didn't think about it at home, but if it's a stalker. He in the middle is a stalker. This person is his stockee. I don't know what you call someone who's being stalked, but that's the prey, the stockee. As the stockee walks around the circle, they live in their regular old life. The stalker's watching them. And no matter where they go, they're just watching. So as they walk around the circle, because it can only go left or right, they can go, oh no, that's crazy, but whatever. They can only go out as far as the person is on the circle. So from here, there's a restraining order. Yes, a restraining order. And this is their house. From home, I can go all the way to your house. It's a restraining order. I won't go in. I'm looking through the windows. Not me. The person, yeah, they're looking through the window. When you go out about your day, the stalker can only go out on this line. They can't go up to you. Restraining order. So when you come up here, the stalker goes as far as it can where they're like, ooh, they're right under you. So when you come here, they don't want to be over here at your house because you're not home. They want to be at the library. So you go to the library. The best they can do, because they can't come to you, they're stuck on this line they can reach out to. So here's what's happening. On the circle, watch the person being stalked. As they're leaving home, they're about to come to school. As they're coming to school, the desire of the stalker is to be directly below them. That's their link. So they're going, the stalker's there. Ooh, here's the best part for the stalker. There comes a point where the person they're stalking actually passes their home. So they don't even have to leave home. They're just looking, they're like, all right, whatever. The person continues on their journey. The stalker, like, oh, they're going over here. Follow them. Boom. At this level here, again, that's the furthest the stalker can be. They're at their friend's house, equidistant. And then the same thing happens again when they go down here. Their distance changes. And the way they stretch this out over here is to say this. The highest or the furthest, really? Can I undo anything? Can I just bring it down like that? No, I can't. Why would it let me just... This line up here, 1 and 1 is the distance you can get from home. And as you travel this circle, which we've now laid out here, it just says what's happening to the stalker. At 0 degrees, let's take it back so I can say it in math talk. At 0 degrees, it's at 1, the longest length. As we go up to 45 degrees, well, the length that you're away from home changes, it shortens. When you get to 90 degrees, you're at a 0. You went like you're right at home. Boom, you go past 90. Again, the length you're going from home increases. It's a periodic function. In other words, at a certain point, the same thing happens all over again. What is it you're about to try and write on your paper? Now, you don't have motion, so you can't quite convey what's going on. Your job is on your paper. If I were doing it, now don't do mine. I took this one, so you can't do this one. It's one of the easy ones. You can't do it. You can choose another. On my paper, I'm going to draw a circle. That's the height of the cosine wave that I drew. Now, those who did like little boxes, it's going to be an itty bitty circle, so it's going to be a terrible thing. But you're going to draw a circle that's 1 and 1 to match your wave. Then you're going to put a point on your circle. I'm putting this point here, and what I'm going to do last is I'm going to, let me make out the whole sine wave so you can see what I'm going to do, and you have to decide where you're going to do it. You have your wave drawn. On my thing, I'm going to put a dot here. Below my dot, I'm going to draw this line here to let me know where it would be on my cosine, on the actual length I'm away from my home as a stalker, and then I'm going to draw a line over here to show where that's represented on this wave. Can you choose my dot? No, you can't. You can choose any other dot though. You could choose, okay, when the person's this far away from their home, the stalker is right here. And so for me, here, are you all the way there? Let me check something online. I think it should be that guy over there, but let me check. Let me check. Right here. Hey, that's interesting. Why aren't you with mine? Why are you over there? Okay. So do this. Keep it on the do it in the first quadrant. That way it'll matter. So do it in the first quadrant. So what is that you're going to do right now? Forget the other quadrants for now, just to keep it safe. Put a point somewhere in this first quadrant, and I guess it can be in my place, and then represent where it would be on this first wave down. Hey, what is he saying? Like, what does he want us to do again? I'm going to do it a second time so you can see me do it twice. That's what you're going to do yours. You're going to choose a point in the first quadrant. You're going to show where that point actually meets on the wave. And you're going to show where that actually is for the cosines right here. Yes?
Can we draw the circle? It has to be on this side, or can it be on
It's supposed to be on that left side, where this part here is technically where they wanted that space to be. And then you have to draw over there. Now, if you want to put it in here so it's closer, where you can see, you can put it right in there too. So attempt to do that. See how best you can do that. You're going to do it twice because we're going to do the same thing with the sine wave. One other thing you should know in terms of numbers, I never even say numbers. The cosine is either the number 1 or it's less, like a decimal. It's like 80 cents, 50 cents. The cosine is never more than 1. Oh yeah, do this part for me too if you get squeezed in. I don't know how small you roll, but just to make a point. Okay, this is $1. Everything here is cents. So let me see, 50 cents, you're about there. So this guy, he's probably like about 75 cents. This guy close up here, he's probably about like close to 90 cents, 95. I'll make him 95. So that you know what the numbers would actually be if someone said, what does pi actually equal? I mean, rather, what does the cosine actually equal at these heights? Think of money. The 1 is $1, and these heights from 0 to 1 are positive cents. I guess you have negative cents, but that doesn't make any sense. Oh, that was sweet if I meant to. I didn't mean it, so. This dot on the circle, how high is it above street level? The dot on the circle, how high is it above street level? That's what sine means. All right, let's try it. I got it at 0 degrees, 90 degrees, the famous ones, 180 degrees, 270 degrees. How high are you above street level is what sine is asking. So let's check it out. And I'll ask someone and see if they can tell me how high above street level. X-axis is street level. At 0 degrees, can anyone tell me how high the dot is above street level?
0.
Yeah, it's at 0. It's on street level, so it's 0. As the degrees increase, it goes higher and higher. The max it can go is that, ooh, dang it, 1 and 1. So let's put you 1, you're -1, your street level. So there we go. So when sine, okay, it's going up, and you can see how the wave happens. You start at street level, which is why you start at 0 with the sine wave. As the degree increases, you go higher above street level. You're the red line, the height. you max out at 1. That's the highest you can go, which is terrible because whatever you just... No, that should be okay. So you max out at 1, then of course you start going back down. Coming down towards street level at 135 degrees. At 180 degrees, you're back to street level. Beyond 180 degrees, somehow you're in the basement, you're subway. So you're in New York. We don't really have subways out here.
LA.
LA, you go underground?
Yeah.
Okay. LA, they got the subways now, so it's going to be like New York, except for the earthquake that just happened. You're going under street level. The lowest you go is -1. At 270, another famous one, you're there, and then finally you come back up, and you're home. What are you doing on this one? The same concept. You're going to put a mark, put a dot on here. That's going to show how high you are. It looks exactly like a cosine, but it means something different. If I were putting a number on this, again, 1 is $1, so anything between street level and $1 is change. Halfway, you know, is about 50 cents, so if you have to put a money amount on it, if you're 50, yeah, you're $1. Halfway between 50 and $1.75, you're a little less than 75, so I'll make you 70.
It's gonna rain again today. I think it's gonna rain
Okay, 20. This is for the bottom of the resource of your key assignment. We are producing this picture, but if you have to produce this picture without it being there, I need you to know you know how to do most of it. So here it comes. Again, you put in your 25, 50, yeah, 25, 50, 75, $1. Below it, of course, put in your numbers, your 90, your 360, 180, 90, 270, same thing you've done a million times. Don't worry about the rest of it. I'm going to tell you about the rest of it in a moment, but for now, get those numbers down. That third row, put in your 2 pi, your pi, half pi, 3 pi over 2. Once those things are done, the part of the picture, I can put in some of the dots so they know, okay. Let's see. I got my dollar, 25, 50, 75 cents. I will be sending this home to you so that, of course, if you want to take a look at it slowly, and of course, you could put in the other numbers below your. This is 360, 180. Hopefully, you've written these things so many times that if you had to produce it on your own, 270. It's right there waiting for you, including your 2 pi. Half of that is just pi. Half of that is just pi. Anybody see the movie The Life of Pi? Anybody see that movie? Did I get a chance to take a look at it? It's the dotted lines are asymptotes. In a graph, you always put dotted lines asymptote. Anybody know what an asymptote is?
Yeah.
Asymptote? Asymptote?
The little line that never touches the actual line, but skims it.
Yes. What you're saying is essentially the concept. The way I say it is an asymptote is a line that a graph approaches but never touches. An asymptote is a line that a graph approaches but never touches. All right, so put in your 2 asymptotes at the magical 25 and 75. Oh, that is so cool. Something is always happening at 25 and 75. So even if I had to draw this, I know at 25 and 75, the 2 dotted lines are coming down the way there are 2 dots on the cosine, the way there are 2 dots on the sine. That is good. That's why I'm a math guy. Because eventually I see, there's a pattern. So now, if I know how to do 1, I know how to do 3. They all have the same money thing. They all have something happening at 25 and 75. Put in your asymptotes, please. And then the last thing you're going to do is you're going to draw these. If you don't do this one over here, that's fine. But these 2 middle guys, you're going to draw the graph, this wavy line. It's going to go through pi. It's going to go through 0. And technically goes through 2 pi. So this is the one time that technically you need a dotted line after 2 pi, or you need something before 0. But in short, reproduce this, draw a circle to the left, and you don't even have to connect anything on the circle. Circle, though you're not going to make that connection because your teacher, I don't know his name, but he doesn't know the connection there. The last thing I'll say about these lines, tangent, this part you do write down. Tangent, I think it's sine over cosine. I hope it is. I don't want to give you misinformation. Yeah. Tangent is sine over cosine. So technically, these lines represent whatever number it equal for sine, whatever number it equal for cosine. Putting in those two numbers as a fraction and whatever it gives you, these lines represent that. But it's too esoteric. Ooh, I learned that word.